Welcome back to the second part of Administer PaaS compute options. Now in this part of the session, we'll have a look at container instances and understand what they are and how we can implement them. So let's get on to it. Now, just to start off with what's our Azure container, or just to understand what containers are before we go into creating one or understanding different use for it. Typically, when you're looking at an example of a virtual machine, you will start off with the details of a hardware somewhere in the backend. So somewhere you'll start off with a physical server. Now, with a lot of the environments, you could just get away without having to have a direct operating system in that environment and going directly into hypervisor. But let's just carry on with the example that we have on the screen, and we'll go into working with a host operating system onto this. Now, this is the operating system that's installed on your physical device that you're working with. On top of that physical device, the operating system that you've installed must be able to cater for you to run a solution called hypervisor. Now, hypervisor is what typically will allow you to virtualize the compute, the hardware that you have on your physical server. Things like your CPU power, things like your RAM, things like some of the storage space that you have on your disk. So let me just write in disk. So again, some of those hardware types that it would need to create a virtualized environment for your virtual machine to run. Now, on top of that, you will go and configure a virtual machine. Now, this is where the hypervisor is virtualizing some of that for you. Now, as you create a virtual machine, as you could have seen in the previous sessions when we discussed the IaaS solutions, you would have remembered we simply start with managing our own operating system. And in that, now this operating system is what we refer as a guest operating system, because it's a guest onto the physical hardware that we are working on. We already have a host operating system that's hosting all of these resources for us. Now, as you go and create that virtual machine, it'll bring its own binaries and libraries for you to then start working with different applications, the runtimes that you need. So it will go and carry on doing that for you. And you can start using an application in that environment and working with that application. Now, the same process will repeat if you have multiple virtual machines, and the limitation of you creating multiple virtual machines will be down to the hardware that you have in your environment and how many times you can virtualize that to create a number of virtual machines. Now, with creating a container in my environment, things look similar, but not exactly the same. So I am back onto working on my host operating system. And on top of that, I'll use an engine over here that can help me in using containers. In this scenario, we're working with a Docker engine that can help me create containers and manage them in my environment. And this Docker engine is what will host my containers. Now, one thing that's straight away different to see first in this part of the diagram, I don't have a need for a second operating system in this scenario. So it will help you understand this particular Docker engine is going to help this particular container to utilize this host operating system. So in this scenario, we are typically virtualizing the operating system or the host operating system for this container. Typically, this container will come with an image running into it. This image is where it has all the details that it requires for this particular tool to run or this app to run. So anything that it requires. This is a lightweight standalone executable solution that I have encapsulated within this environment. So it does not need anything else to run apart from it to be plugged onto an operating system and utilize some of those features from an operating system and start functioning. So when I place an image in a container and plug that container onto a Docker engine, it starts utilizing the operating system that it's working on as pretending as that application is running on that operating system. However, it's running within a container environment. Now, a few things to discuss as part of this concept, as long as you understand that right now I'm using a solution to run my app without having the need of an additional operating system, which my virtual machines would do. There are a few things that can straight away help me in understanding this. Now, one thing is how fast is this particular service as compared to me running a virtual machine? Now let's, for example, suggest I have an error with my virtual machine. Now, whatever this error can be, the guest operating system is crashed, some sort of an issue with my binaries libraries and my app has crashed and is hung my virtual machine and I need to restart it. Now, one way of this would be to completely shut this down and restart. Can't work it with it still. I can simply crash this entire virtual machine and recreate another virtual machine. Again, we've created virtual machine in Azure environment before. You might have seen how long it takes to do that. It takes a few seconds. Well, let's assume a minute or just over a minute for it to happen. Maybe on your own servers, depending on the hardware you have and the setup that you have, maybe about a minute or so. So this is what you will need to do. Once you've reconfigured it from scratch, you might have to reinstall the operating system. You might have to bring it back to life. Now let's assume it's not completely gone and it was just hung, so we're restarting it. So the time it will take for me to rework with it will be as long as the operating system needs to reboot. Once it's up, click on the application back in and we're back into working with the virtual machines and the app on it. Now, as compared to my container instances, if a container is stuck or the code within that with the image that I'm running for application is stuck for any reasons, and let's assume this container is now not responding. Now, for me to restart this, I can simply crash this whole container and restart it, or delete this container and rebuild a new container. All I need to do is pull the same image that I did in the past. So I have my image ready to go. Pull the image and plug it into the container and plug the container onto my Docker engine. Now in this scenario, or in both these scenarios for the container, if I'm just restarting the container, it happens within seconds. It does not require a new operating system to, or existing operating system to reboot and go back into the application. The operating system in the backend is already running. I am simply restarting the app. So the time it takes for the app to run, that's all the time it will need if I'm restarting the container. Now, if I am rebuilding the container, it's the time that it needs for the image to be pulled and be ready for me to plug into, as compared to me creating a new virtual machine. As you can imagine, that takes time for you to pull an image for an operating system, configure it, log into it for the first time, and then bring your application into it. That takes a little bit longer than a minute or two. And in this case, that can happen in a few seconds again. Now, this is where we are looking at comparing the two different solutions as compared to containers to virtual machines. Now, apart from that, if I look at the details, like I mentioned, my containers does not need its own operating system, whereas the virtual machines are always running with an operating system in the background, so it always needs its own operating system. This brings a question in mind: isolation. Typically, when you're working with an application, let's assume I'm working with this application called App A. This is hosted onto a guest operating system for me to work with. If I'm working with App B and I'm hosting some of that information in App B, then in that case, this is hosted on a separate operating system. Now, there's no chance for this data or any sort of information moving from this operating system to my hypervisor, or going even as far back down into my host operating system, going across to the other operating system and the other app. So it's completely isolated because it has its own operating system. It doesn't even need to go into the kernel or the operating system that I have as part of my host. So it stays and maintains that within that virtual machine as a completely isolated instance. Now, as compared to my containers, a lot of the time people assumed that because this is a container and it's utilizing the host OS and it's working on the host OS, if I have multiple applications working and using the same host OS, there is a chance that they're not well isolated and there can be some sort of corruption, some sort of data moving between the apps because it's using the same OS. However, Microsoft ensures that this is not the case. Using container instances in Azure, they are completely isolated as well as a virtual machine isolation. Now, in terms of persistent storage, this is interesting. We spoke about virtual machines in the previous module. We spoke about adding a disk space to the virtual machines. In fact, let me not draw a layer right here. What I am going to do is I'm going to suggest that we have a disk space allocated from the server. So this disk that I mentioned earlier on, so part of the disk size that you have within the physical server is consuming a small space and allocating that small space to this virtual machine as it's virtualizing the hardware. So we could have a potential option there to think, let's add the data that we need to work on within this app or from my solution into the same disk space that is using for the OS disk space for this virtual machine. I could choose to do that. However, I do have other options as persistent storage. I can bring in other solutions to my virtual machine, things like adding an additional virtual hard disk, which we spoke about in virtual machine session. Along with that, in storage, we spoke about something called Azure Files. So I can actually host my Azure Files, and we did a demo on this as part of my storage solution, where I went onto a virtual machine and I hosted a Azure file and mapped a drive from my Azure Share to my virtual machine. So we could use some of those solutions that we have for persistent storage if we don't want to carry on doing that. Now, similar for the container instances, they don't actually have much space or built in for the containers to have any space for data to be added to it. That's not the way the containers are designed. Like I said, they're lightweight. They're not designed to have additional spaces for extra data or to add data into it. Now, for containers, we must have some sort of persistent storage added to it. So as and when you're working with your app inside of a container, you might need to keep that data stored as if I need as a result of a process or an application I'm creating something with or other things, I need persistent storage as part of that. Now for this, it will become important for me to start looking at adding persistent storage. Now in this scenario, I can do but similar. I can bring in back the solutions that we're using for a virtual machine in this case. So instead of adding it just to the virtual machine, I can think of adding virtual hard disks into my container instances, or I could bring in Azure Files in here as well and map them to my container. And this is where they can use this as a persistent storage for me as well. So again, both the solutions in both scenarios, we can use similar situations. However, good to know that by default, the virtual machines might already have some disk space that I can rely on to, whereas containers won't have that space by default running into them. Now, I am hoping this has given you a quick understanding on what is the difference between a container as compared to a virtual machine. So earlier in the demo, when I was creating an app, I used a container image. You saw me pull a container image from the quick starter template from Microsoft Container Registry, and I simply created the app that we had in the previous demo, even though it was a very simple page with some graphics into it, but it took literally a few seconds for that app to be ready. And again, this is something that you can do in terms of bringing different solutions within your environment using containers. Now, apart from just discussing how we can use containers or the advantages of having containers as compared to virtual machines, we can also talk about some other options. Now, my container instances can also have direct access to the internet. We can provide them public IP address, have ports allocated to them so they can have networking enabled to them. So if I needed to have connection to them to work or use other things, we can allocate that feature to my container. However, typically when we are working with solutions in our environment, we can look at containers or multiple containers working together to help me with creating my solution. Ideally, you want to host one app per container. You don't want to have too many things happening in a container. And if you do need to host multiple things, there could be dependencies of your app within a single container. Ideally, you want to split them out, and if you have multiple apps, run them in different containers if you possibly can. Now, if I look at a solution that I have on the screen, this is where I can see I have some sort of a web service that I've got running as part of my setup. And as part of that, I might need to have access to some back-end resource that I might want to work on. It could be that it's looking at some sort of a data source, could be some data running into it, some storage solution that I'm running into it. And I'm working with an app service that might need access to some of those resources. As part of the app, I'm either storing data in some storage or in a database. So I want to work with multiple solutions in that environment. Now I can host multiple solutions as together in this environment. This is where we can bring in that conversation of creating a container group. So we can bring them both together. Typically in the back end, these are hosted on the same resource when you're creating a container group. So they share a same life cycle as part of that container group. So if you're working on a project and you have multiple requirements of a solution, keep them in the same container group. That can help you manage on how you're working with things. Again, for persistent storage, you can add Azure File Share to it as well. However, you can create an access to that from public resources. You can have a public IP address assigned to it. You can also create a DNS name to it and have a web link going onto that container. So in this scenario, I might want people just to access this web service from over the internet and not see the backend service that I've got running, either as a storage or database or whatever that's connected in the backend to it. And again, isolate that connection coming in. So not allow connection directly to my backend space that I have for storage in this scenario. So I can plan to create container groups to group these solutions together in my environment. Now, typically when we are working with containers and looking at creating different solutions with containers, there could be a potential use for me to use, instead of one container, of a group of containers with 3 things into it. I might look at creating a solution that is like my microservices, splitting down my entire solution in smaller containers and then implementing that out to make sure I have a way of running a solution so there's less downtime. So if I have an entire payment system plan created for an organization, or let's say for a supermarket or some other solution or similar solution for an online site, if a part of that service is broken, I don't want everything to come to a halt. We could simply go into that microservice and look into that particular container that's not functioning and reboot it, recreate it, bring it back up. Again, building that fault tolerance in case if it fails, we restart and we bring it back up. Now, for us to do that, typically you're looking at a solution that can help you manage a lot of different containers and microservices in your environment. Typically in Azure, you'll look into managing an Azure Kubernetes services. Now, Kubernetes services on its own is a huge topic and covers a lot of different, or requires you to understand a lot of different details. And you need to understand how to master that before you can start implementing them. Now, if you need particular specialized people who work with Kubernetes services, and you don't have those people in your environment, but you still require a solution that can cater for some of those for you in that environment, we have a solution in Azure that we can use, which is called Azure Container Apps. Now, Azure Container Apps is a managed serverless containers, and this service offers an ideal platform for application developers who want to run microservices in containers without managing infrastructure optimized for running general purpose containers. Now, especially for applications that span many microservices deployed in a container, powered by Kubernetes and open source technologies like Dapr, Kda, and Envoy. Now, distributed application runtimes Dapr provides you the APIs that simplify the microservices connectivities. The Kda or Kubernetes event-driven autoscaling is used for autoscaling. Your Envoy could load balance the traffic for you in that environment. Now, this distributes the traffic efficiently across your microservices as you work within that scenario. Now, the supports for your running on demand and scheduling and event-driven jobs is part of all that what Envoy can provide. Unlike Azure Kubernetes Services, Azure Container Apps does not provide direct access to the underlying Kubernetes APIs. If you don't require that direct access to all the native Kubernetes APIs and clusters that are running in the backend, then in that case, Container App provides a fully managed experience based on the best practices available for you. Now, this is a solution that you can patch up as a result of using, or instead of using Kubernetes, simply because it caters for all the features for you in that environment without you having to have a need for experts that can manage that environment for you and still run your microservices in your environment by simply using Azure Container Apps. Now, this brings us to the end of this part of the session and end of PaaS compute services. As we conclude this module on administering PaaS compute options, let's recap on the key points we've covered. We explored various compute options available for administering platform as a service in Azure, including configuring app service plans, Azure App Services, and Azure Container Instances. We delved into the practical aspects of creating and deploying container apps and verifying their deployments. By now, you should have a thorough understanding of how to effectively manage and scale Azure compute resources to meet your needs. Remember to review the reference modules and check your knowledge with the additional study materials provided on the Microsoft Learn using aka.ms/learn. Thank you for your participation, and we look forward to seeing you in the next session.